Hello, welcome back. We are talking about last time with temporary variable. What are those things? And if you look at the current code of ours, we have this local temporary variable, this amount here, and repeated and used in these three places. And when we are talking about temporary variable, these are sometimes a little bit bottleneck for the next if you want to do refactoring. So often a problem, as it says over here, and that they may cause a lot of parameters to be passed around when they don't have to be. Okay. Of course, there are cases you can do that. These are not, what is that, carved in stone, but these can be according to situation you need to act. You can easily lose track of what they are there for, and they are particularly insidious in long methods. So we need to get rid of temp variable first, and this may lay the groundwork for applying extract method for a portion of a very long method. So what can we do about this amount temporary variable? Let's see one more time. Here is the this amount. At the very beginning, when you look at these kind of things, firstly, what is important is first you identify the problem. This could be a problem for more refactoring. And then second, and how can we refactor this? That is another problem. And then refactoring it. So we need to study code, as you know, we need to study. It is not easy, just not doing the job, but actually the initial part is really important. Why this local variable is not good? Because it may cause we need to send a lot of parameters to a lot of places. So if you are doing that, things become messy anyway. So we are not doing any good to us. So when I study this amount, look at here, always in the while loop, this is created and set to reset to 0. And when I say 0 plus something, it get charged. So actually this amount equal to each get charged because I'm not changing anything. And this amount is being used and nothing added to this one. This is not modified. Only here it's modified with this one. And this rings a bell a little bit. Looks like I can call wherever it needed. I can use each dot get charge, right? And I can replace all this amount with each dot get charge, so I can get rid of this amount. Let's look at a little bit slide. And you are using temporary variable to hold the result of an expression. Extract the expression into a method. Replace all reference to the temp with the expression. The new method can then be used in other methods. So let's look at simple code. So we have here calculate total function, and we have here base price. Base price is quantity time item price. So this is the temporary variable, which is base price, and base price is used over here, here, and here. So what we can do is we can extract this part into its own function and call base price calculator, this one function. As you see, if there's a parenthesis, this means a function. And we do this math over here, and we can call for this one. Of course, the first thing comes to your mind, the performance. Oh, you are repeating this calculation 3 times. But premature optimization is the root of all evil. Maybe you heard this one. So you don't know whether this code is guilty. Maybe this code is not called frequently, maybe once in a while. So don't try to optimize it. Firstly, performance-wise. First, you refactor it, and then later on, if there is a problem over there, now you have a place to fix it. Okay, we can consider that one. Otherwise, each code is innocent unless it is proven guilty for performance wise. So how can we do step for replace temp with query? Find temp with a single assignment, extract right hand side of assignment, replace all references of temp with a new method, remove the declaration and assignment of the temp, compile and test. We can do that. So some of the benefits is code readability and slimmer code. Let's look at this one. Instead of you say get tax, if you do this one, order price times 0.2, what does this means? But get tax is much clearer. And I'm going to move everything in here, right? This is great. This is much better. This is not good. And similar code, we had the deduplication if the line being replaced is used in multiple methods. Okay, so currently the examples we gave is not used many places, but now we will be code deduplicating this one. Of course, don't worry about performance as of now. Its code is innocent. Okay, let's try to do this one together. So in this case, there is on right side, as you see. So we have already extracted this get charge. So what I will do is, actually I don't need this code anymore. I'm gonna comment out this one. When I comment out, this one's gonna scream. And then, do I need this amount in anywhere here? No, I need in here. So I'm gonna copy this one and change this amount, get charge, and we are adding the total amount, get charged. This is cool. I don't need this one, right? I'm gonna get rid of it. So deleting some extra lines and test. All green, all is well. I got rid of this amount, and let's get rid of this one too. As you see, my code becomes slimmer and slimmer, and we have more stuff to do. But let's look at here one more time. So here is this amount used to be, right? And we need to study, of course. That's important. That's the hard part of it. And before that, what's hard part is we need to be a little bit get bothered by the temp variables if we are doing refactoring. Getting rid of is important. That is important. And now how can we refactor? We got it. So what we have done is just called get charge wherever we need it. Look at here, we need in here and here, and these are assignments doing nothing, so we don't need these two lines. So this is perfect. Always compile and test with small steps. We have done already this one, right? We have done it. Great. So this is working. But again, a word about performance. It is here, Donald Knott. Premature optimization is the root of all evil. The best way to optimize performance is to first write a well-factored program, then optimize it. Okay? Later you can run profiler. Yes, profiler is a tool which will say how many milliseconds is passed and spanned each time, and where is the bottleneck, which function or which line of the code is very frequently called and takes a lot of time. So find the problem and hotspots, and then you can fix it. So each code is innocent unless proven guilty. Okay, just remember that. So the next question I'm gonna leave you with is this one. What can we do about frequent renter points calculation? Can we extract it into a new method? Let's look at the code a little bit and then see the problem is a little bit larger. This frequent renter points over here. If you look at here, it is incremented in this, and again it is incremented, and it's used over here. Inside the while loop, we are updating it. The frequent renter points is over the rentals, so we are visiting each rentals, and then this is a little bit harder, looks like, and you want, maybe you have a little bit reluctant, I don't want to do this refactoring, but you will see the benefit later on. Okay, I'm leaving you with this question. So what can we do with this frequent rendered points calculation? Can we extract into a new method? That's the question for you. I'll see you in the next video.